So if you're asked to find an equation of a line of best fit, well, we know an equation of a line is y equals mx plus b. And what is a line of best fit? Short form, I'm writing LOBF, line of best fit. What's a line of best fit? What does that mean? So when you're drawing your line of best fit, you're drawing the line as close as possible to all of the points. Remember we talked about this on Monday? So copy that down as well, as close as possible to all the points. So you're trying to have an even number of points on both sides of the line. The point of this is to have a line that's close to your data. So step one is to graph the data. So you're going to create a scatter plot, like you said. Okay, so we're graphing the data, and the example we're looking at today was comparing what? So we need to choose two coordinates on, this is the key word here, on your line of best fit. Not 2 points that are on the graph, but 2 points on your line. So I want everyone to watch how I choose the points here. Remember, the activity here is to find an equation of a line in the form y equals mx plus b. In order to write an equation, I need to know m and I need to know b. So the first thing we're finding is m. So we're going to calculate the slope using the 2 points that you chose and the slope formula. y2 minus y1 over x2 minus x1. Okay, so you're going to use your 2 points and calculate the slope. Okay, so we found the slope. Now we have to find b. We have to find the y-intercept. So we're going to plug in one of the coordinates, x and y, and now we know m, and we're isolating for b. At hours of TV that a student watches, how many hours a night, and their grade. Okay, so here's the data. And does everyone agree that the line that was drawn is close to the points? It's a good line, it's a good fit. Would you say that this is a good line of best fit? There's roughly an even number of points above and below the line. It would not make sense for me to draw my line over here. That's nowhere near the data, okay? Does everyone understand that? So if you were to describe this information, this data on the graph, how would you describe the trend? What would you say about this class that was surveyed? How would you describe their marks based on the hours of TV they watch? Yep. As hours of TV increases, so as they watch more TV, their mark, so their percentage, decreases. Okay, and we can see that this is a graph that's decreasing. There's a strong negative correlation. It's decreasing. As they're watching more TV, their mark seems to be going down. That's a trend in this class. Is that true for every single student, though? Not necessarily, okay? But that's the trend. We're looking at a pattern to describe what's happening in this classroom. So our goal is to find the equation of our line of best fit. This is the line of best fit. I want to know what is the equation in the form y equals mx plus b of the line that we drew, okay? The reason we're finding the equation is so that we can use this equation to predict data, to predict information, okay? So let's talk about that after. Let's figure out the equation first. I'm going to choose 2 points on my graph that would be easy to read. So let's go with, I'm going to choose this point here, 9. This is on my line. I'm gonna estimate that to be 9. What would you say that is? Where is that located? 41, 940. Let's just say 9. Let's round it to 940. So there's a point on my line that's located at 940. You're not copying mine, you're looking at your line. And another point on my line would be at, I'm going to say right here. So again, you're choosing a point on your line. I'm not circling one of the points I graphed. I'm choosing a point on the line. Where is this second point located? 2, what? 80. I'm going to label my points A and B, okay? And if you look here, does it look like it intercepts roughly around 91.4? Is that my y-intercept? 91.4 looks like it's the correct intercept. Compare your value of b to your line. Extend your line. The equation of my line is y equals negative 5.7x plus 91.4. Now that I have an equation, I can use the equation to make predictions. Yep. What did x represent? What did I graph on the x-axis? What does x represent? So x represents the hours of TV, and y represents the student mark. So if I ask you right now, if the student watches 0 hours of TV, for example, according to this trend, what would be a good prediction to say what their grade might be if they watch no TV, according to my graph? Yep. 91.4%. Does that make sense? If a student watches, let's say, 12 hours of TV, I want you to tell me, if x is 12 hours, I want you to tell me, according to this trend in the data, it's not going to be true all the time, but according to the trend happening, what would be a good prediction for what their grade might be according to this pattern? They might roughly get around 25%. And we can even use the graph to check that. Extend your line. 11, 12 hours would give me roughly around, does that look like it's located at 25? Yeah. So you can use the graph or you can use your equation, okay? If you're extending your line, it means you're extrapolating the information. So my y2 is 40 minus y1 is 80 over 9 take away 2. 40 take away 80. Negative 40, 9 take away 2, 7. What is negative 40 divided by 7? I want you to write it as a decimal so we can compare each other's. Negative 5.7. Okay, I'm rounding it. Okay, so I'm going to use coordinate A. I'm going to plug in x and y. Y is 80. My m is negative 5.7. My x is 2. And we're finding b. Therefore, b is equal to 91.4. Okay? Once we know m and b, what is the final step? What do I have to write now? And so, final step, therefore, the equation of my line of best fit would be y equals negative 5.7 x plus 91.4. And let's look at our graph and see if that looks reasonable. My y-intercept is roughly at 91.4. I'm going to go back and look at my line and see if that makes sense.